Good morning. So today we're looking at question 4 from the Metro Central Education District. We're looking at the common paper, September 2021. We're looking at question 4. So in question 4 we are told that the diagram shows the hyperbola defined by g of x equal to negative 4 over x plus r plus t. The graph of g of x, probably g cuts the y-axis at 5, the asymptotes of g both cut the x and y. So the equation of the asymptotes cut x and y at 1 and 1. Okay. So all that information is on the diagram. Alright, so first question. Write down the value of r and t. So let's go to 4.1. Question, okay, just get the equation. As you can see, t is your horizontal axis. That is straight. So we can say t is equal to 1. However, r is also equal to, okay, so r is going to be negative 1. Now, many learners wrote r to be positive 1 because of this here. Remember that if I substitute this back, g of x now reads g of x is equal to negative 4 over x minus 1 plus 1. And remember that the denominator can't be equal to 0. And when is this denominator equal to 0? When x is equal to 1. And that's where the asymptote occurs. So many students wrote t is equal to positive 1. So watch out for that. Remember, sometimes they give you the formula in this form. If the formula is given in the form of g of x equals negative 4 over x minus r plus t, then r is equal to 1 and t is equal to 1. Why? Because if I substitute it back, g of x is equal to negative 4 over x minus 1 plus 1. Okay. Okay, just hang on. Let me just pause here quickly. Okay, so as I said, it depends on the form that is given to you. Okay. So if it's given in this form here, this r here particularly, then it's going to be, r has to be positive 1. But it was given with a positive there, so it's not going to it's not going to be a positive 1, but negative 1 in this case. Okay. Let's take this out. Right. So in 4.2, in question 4.2, we are told write down the equation of the axis of symmetry with a negative gradient. Remember, there are two axes of symmetry in this graph. One going through like that, with y is equal to x plus c, that has a positive gradient which doesn't intersect the axis. And the other one going through like that. It's a negative gradient, so y is equal to minus x plus c. So it says with a negative gradient, or the axis of symmetry that intersect the axis, I mean the hyperbola, of course is then going to be that one. So we say y is equal to minus x plus c. We substitute the point that lies on this graph. The point that lies on this graph is that there, which is 1 and 1. So you'll substitute 1 and 1. So 1 is equal to negative 1 plus c. So c works out to be 2. So the equation they're looking for there is y is equal to negative x plus 2. Okay. And then the last question, okay, don't need all that space. The last question says write down the equation of the vertical asymptote of g of x plus 4. So if you're looking at this graph here, what is the current equation of the asymptotes? The equation of the current asymptotes. Okay. So the equation of current asymptotes is y is equal to 1 and x equal to 1. Okay. The vertical asymptote, this is this asymptote referring to. So what effect does plus 4 have on the graph? This graph is actually moving 4 units to the left. If it's plus, it moves to the left. If it's minus, it moves to the right. It moves 4 units to the left. So if it moves 4 units to the left, the axis of symmetry, not the axis of symmetry however, but the asymptotes also move 4 units to the left. So 1 minus 4 is going to give you negative 3. So my asymptote now occurs at negative 3. This horizontal asymptote remains a horizontal asymptote, and this would have been the graph. Okay, the question wasn't to draw the graph. I'm just showing you what's happening here. So again, write down the equation of the vertical asymptote. Therefore, x has to be equal to -3. Okay.